Hello everyone, welcome to another chemistry video. This time I'll be going over sort of an intro to thermochemistry, and I'll be going over these two topics. Firstly, delta H or enthalpy, and then whether a reaction is exo or endothermic based on the delta H, as well as phase, because that's a little bit confusing. Alright, so firstly, what is delta H? Well, enthalpy is kind of a measure of energy. So it's sort of like kinetic energy, except in chemical form. Generally, the most basic kind that you'll see is delta H, F. So F stands for formation, and that's like if you wanted to form this substance from its components, how much energy would it take per mole? So generally it's in joules per mole is the units, or kilojoules per mole. So enthalpy, it's not exactly energy, but you can think of it as a change in energy. So in the same way that like a change in voltage does not really mean anything on its own, like if you just said what is the voltage, that doesn't really mean much unless you have somewhere to compare to, like a baseline. And for enthalpy, the baseline is STP, so standard temperature and pressure. I think it's 1 atmosphere. So that is generally where it's at. So the analogy with voltage, essentially, on either side of a resistor, if there's some electrical current going through it, then if you have two different points on the left and the right side, then you know that the voltage here is going to be different from the voltage there. And so if you were to consider like what's the voltage here without knowing anything else, you couldn't really tell because you need something else to compare to. It's relative because it's change. So you can't have change with only one data point. Alright, so that's enthalpy. You can think of it as like, well, here's another example. So generally the enthalpy of gases, liquids, and solids goes like this. So a gas will have more enthalpy than a liquid than a solid. So you can think of it as like there's more kinetic energy in gases than in liquids, and liquids have more kinetic energy than solids, and that's because generally like the particles move much faster in gases than liquids than solids. So delta H or enthalpy, it can also tell you sort of whether a reaction is exo or endothermic. So if you look at this, right? So this is going to be time, and then this is like a reaction graph. So I'll just put energy here. So this is like the energy of the combined reactants and then the products. So if you see this graph, then you can kind of tell the energy goes down, right? So it goes down by this much. And that is known as the delta H, or enthalpy. So here, delta H is less than 0, or it's negative. So that means that your system lost energy. That means the outside of the system gained that energy, because energy has to be conserved. So this would kind of be like if you were to combust something like ethanol. You combust ethanol, it becomes a lower energy form, and then it releases energy outside. So you can see the fire. Or actually, I don't think you can see the fire with ethanol, but gasoline, for example, you can see the fire. Okay, so the opposite is also true. I'll draw it just like that. Okay, so in this case, we've actually risen in energy level. So that means delta H is greater than 0. And that means it's now endothermic because the environment is giving our system energy. Now, how this relates to the phases, gas, liquid, and solid, well, when you transition between phases, there's a very obvious delta H. It has to do with sort of the energy level of the thing. So if you go from gas to a liquid, and assuming you're the same substance, that's the same element or compound or molecule, if you were to, like, for example, go from water vapor to liquid water, then that means delta H, well, you've gone down in energy level. That essentially means that delta H less than 0. And now, let me draw a relation between the sign of delta H and the exo or endothermicness, I don't know if that's a word, of the reaction. So this is exothermic because delta H less than 0, we lost energy. That means we released energy into the outside. Now that's a very confusing concept for some people, right? Because it's kind of like you're saying, like, you know, we lost energy, but we also gained energy. What's really going on here? Releasing energy means that the thing itself lost energy. Releasing is like, sort of like if you sprayed water out of a hose, the hose has lost water, but that's the releasing, but it has created more water, if you can understand that. So the hose has lost water. That's like going to a lower energy state. And then by releasing water, that's like the exothermicness. So I hope that makes sense. So anyway, here, this is exothermic. Basically, anytime you go to a lower energy level, it's going to be exothermic. So the question is, if I were to put water in a freezer and then the water freezes, is that reaction exo or endothermic? Please take a moment to answer for yourself, and I will reveal the answer now. So that reaction, we go from a liquid to a solid, and that means delta H is less than 0. I think that makes sense. No, so it is exothermic. Now, a place where people trip up is, this actually happened today in class. So someone said that this is endothermic because the freezer is providing energy to the liquid so that it can freeze. Now, this is actually not true because when the freezer has any interaction with the liquid, it's the exchange of energy. It's not freezing energy or like frost power. It's not like that. It's like someone's losing temperature, someone's gaining, or someone's losing heat, someone's gaining heat. And in that situation, the water loses heat, the outside freezer gains heat. Even though that sounds kind of weird. So, yeah, it's exothermic because you've gone to a lower energy state. So I think that covers everything. Okay, actually, so there's many types of enthalpy. So I only covered like, I only covered like a general idea, but there are many types. So there's like delta H subscript F. So that means formation. So like, for example, water is made like this. So this is like I think they start off as gases, I'm pretty sure. And then it turns into water or liquid. I'm not exactly too sure, but it might also be a gas here. I think the only difference is like the amount of heat it takes to change water into gas. But anyway, this is like generally correct. Let me add a 2 here. So in this situation, the delta H formation, the enthalpy of formation of water, is defined by the enthalpy of formation of these two things. Now in this case, something important to note is that when something is in sort of, you can call it its natural state that it wants to be in, like hydrogen and oxygen at equilibrium, or not equilibrium, at standard temperature and pressure. So like, you know, oxygen always wants to be a gas. Hydrogen always wants to be a gas, and also they want to be diatomically paired. But water, I think, wait, let me see. This is like 23 degrees Celsius, I believe. So it actually doesn't want to be a gas. So there would be some enthalpy of formation. You would have to make some change in energy, in heat, to become water vapor from the liquid water. So I hope that makes sense. There's H formation. There's also delta H. There's a lot of types, but formation is very common. I think another one is bonds. So the delta H of the bond. Let me see actually. So types of enthalpy. I have to take out my notes. So there's like combustion. There's the bond. Neutralization. But most commonly, you're probably just going to deal with formation. So that's about it for this video. Thanks for watching, and see you guys next time.